Now the next topic is bottom-up parsing in Unit 2 in compiler design. So this is the another technique of syntax analysis. So bottom-up parser which constructs a parse tree for an input string which is beginning at the leaves, that is at the bottom, and working up towards the root, that is from bottom to top. It is also called bottom-up parsing. So we can think of this process as a reducing. So shift reducing. Okay. So a string W to the start symbol of a grammar. It is also known as shift reduce parser. So because its two main actions are shift and reduce. So at each shift action, the current symbol in the input string is pushed at a stack. At each reduction step, the symbols at the top of the stack, it is this symbol sequence of right side of a production. So right hand side of the production will be replaced by the non-terminal at the left side of the production. So rightmost derivation will be applied in bottom of parsing technique. So in bottom up parsing, we have shift reduce parsing. Yes, LR passes. Okay. So in top down parsing, we have predictive passes or LL1 passes. So shift reduce. In bottom up parsing, it starts from the leaf nodes of a tree and then it works with upward direction till it reaches the root node, right? So here we start from a sentence and then apply the prediction rules in reverse manner in order to reach the start symbol. So the image is, we can see the images here. Okay. So here we have shift reduce passes, which is uses two unique steps for bottom up parsing. So these steps are also known as shift and reduce. So the shift step refers to the advancement of the input pointer to the next input symbol, which is called the shifted symbol. So this symbol is pushed onto the stack. Then the shifted symbol is treated as a single node of the parse tree. So one more thing is reduced term. So when the parser finds a complete grammar rules, that is RHS, and replaces it with LHS, it is also known as reduce step. So this occurs when the top of the stack contains a handle to reduce a pop-up function. It is performed on the stack which pops off the handle and replace it with LHS of the non-terminal symbol. So a shift reduce passes try to reduce the given input string into the starting symbol from string to the starting symbol from bottom to the top. So at which reduction step a substring of the input matching to the right side of the production rule, which is replaced by the non-terminal at the left side of the production rule. So if the substring is chosen correctly, then the rightmost derivation of that string is created in reverse order, right? So this is an example for shift reduce parser. Consider the following grammar. S implies AABE. So A implies ABC or B. B implies D. So for the input string here, AB. So consider this input string. We are going to apply the bottom up parsing technique here. So for this, we are starting from what? The leaf node. So the leaves are here we are taking from the input string, but in the top down we are taking started symbol, right? But in the bottom up parsing we are taking input string and we are going to the passing to the root. Okay, so consider this symbol A B B C D E. So this is a given input string. For this we are going to take a reduction process. Okay, so what is B here? B is nothing but we can replace it as A here. So next you can write it as same B C D E. Again ABC means here this ABC is replaced with again this production, that is A here. So remaining D is written as same here. So AAB again right side of the production BE here. BE is not, so DE is nothing but B here. So D is replaced by B here. So that is the production AABE. So AABE is nothing but root node. So from the input string from the leaf node, we are passing to the upward direction. That is root node S. So this is the example how we have done. Okay, so these are the reductions in fact which can be trace out the following rightmost derivation in reverse order. Okay, so rightmost as we have discussed, bottom up passing always done in rightmost derivation, top down passing is always done in leftmost derivation. Okay, for example, consider the following example. Beginning ABBCD is a right essential form whose handle is A implies B at the position 2. So AABCD we are replacing is a right essential form whose handle is A implies whose production we have A implies ABC at the position 2, right? So sometimes we say the substring beta is a handle of A beta W. If the position of beta, the production A implies beta, we have a clear information that it is replacing with a beta. So see the one more example for shift reduce parser. Here the production is given E implies E plus T or T. So T implies T star F for F. So here F implies left parenthesis E or right and right parenthesis or ID. So rightmost derivation of ID plus ID we are going to expand this. So rightmost derivation we have to make it here. So A plus, so consider the first production with the start symbol. The start symbol is here E plus T. So E plus T is replaced, T is replacing because we are doing here rightmost derivation. So T is replaced with T star F here. Again T star F is replaced, rightmost derivation we are doing. So F is expanded. So F is nothing but here ID, right? So here again for this production T is replaced with F here. So E plus F star ID. So E plus ID star ID. F is nothing but again ID here, right? So here again E means T here. E is nothing but T here. Again T is nothing but F. F is nothing but ID. So that will become ID plus ID star ID here. So rightmost essential form here in table form, we are passing the table. So consider the input string and pass the table here. So Heidi, you are entering into the stack, right? Stack we are taking. So entering into the stack as ID. So what is ID here? What is the production is applied for ID? F implies ID here. Again, F is replaced, ID is replaced with F. So ID star ID. Again, so here we are entering into stack. So F is nothing but T here. So left side we are replacing T implies F. So F is replacing with T here. So T is nothing but again E implies T. So T is nothing but again E implies T. So T is replaced with E. So in rightmost derivation in bottom up passing, we are doing the uh, replacing order in a reverse order. So T is replacing with E here. Here E is replacing with T, but in this form, we are replacing T with E here. Again, so for same ID, we are doing the same operations. T, F implies ID, same thing is repeated as we have done in first step. Okay, so for first ID, for F implies ID, T implies F implies again ID. So here, why we are replacing T implies T star F because we have the production star here. So we are replacing star production here. Okay. Again for T star F means here. Again T here. So this is replacing again with the E only. So E plus T is replacing with E only. So from the input string from the leaf node we are moving to the root node. So this is called bottom up parsing. So for given input string, you have to parse and you should get the start symbol. Always you are parsing from the leaf node to root node here. So what is the stack implementation of a shift reduce parser? So there are four possible actions of a shift parser action. First one is shift. Second one reduce. Third one is accept. And fourth one is error. So first, the next input symbol is shifted onto the top of the stack. So reduce means replace the handle on the top of the stack by the non-terminal. So accept states successful completion of its parsing. Error means parser discovers a syntax error and calls an error recovery routines. So initial stack it contains only the end marker, that is dollar symbol, and the end of the input string is marked by the end of the end marker. So when this marker is occurred, that is the end of the input string. So see here in the stack implementation, we are taking the initially we are taking the dollar symbol. So id plus id star id, it is again taking uh, dollar symbol. It means that it is the end of the input string. So id we are passing one by one into the stack, right? So first id we are passing. So remaining what is left over here, this id is passing here. So plus id star id then dollar. So reduce by f into id. So this is meant by f here. Again same production will be executed. Same input is passed. So again f means here t. F means here t. So t means e. E means then again up to here. So once the root symbol we have occurred, then we have to shift to the next symbol. That is shift to next symbol is plus e plus id star id dollar. So here also again we have to we don't have any production for e plus. So again shift, we are making the operation action, that is shift of action here. So again this id is shifted to the stack. So e plus id again reduce, it is reduced to f and reduced to t, and again this star is shift. So there is no production with e plus t star. Again we are shifting id to the stack. So it is id means here again f, t star f means t. Again e plus t means we have the production e here. So finally we got the end of the table. We have got the root root symbol here. So that is start symbol, which is accepted say. So this is our pass tree, which is constructed based on these actions. Okay, this is all about LR parser, how we are going to parse the input string, how we have constructed the bottom up parsing. Okay, so next topic we'll discuss other techniques in the next class. Thank you for listening.